Hello, I'm Erica Salazar, a PhD student in the Nuclear Science and Engineering Department at MIT, the Massachusetts Institute of Technology, and I work on superconducting magnet research for the Plasma Science and Fusion Center. It's Friday, the 30th of April, and this is your Fusion News Update. Stories today include 1. Assembly of ITER magnet system starts. 2. DOE pushes for aggressive U.S. investment in fusion energy. 3. Team improves polar direct drive fusion neutron sources for use in laser experiments. 4. Phoenix receives $2.5 million contract from DOE for fusion energy technology. 5. Atkins wins design contract for world first fusion energy research center. And I've got a bonus for you at the end. 1. Assembly of ITER magnet system starts. The 6th colloidal field coil of the ITER tokamak was inserted into the Fusion Machines tokamak PIC on April 21st. The milestone marks the beginning of the assembly of the ITER's magnet system, which will control the shape and stability of the ITER plasma. First plasma at ITER in Cadarache, France, is planned for 2025, with deuterium-tritium fusion experiments commencing in 2035. The coil was manufactured by the Institute of Plasma Physics of the Chinese Academy of Sciences. It has an external diameter of about 11.2 meters and weighs 350 tons, making it the heaviest of ITER's superconducting magnets. 2. DOE pushes for aggressive U.S. investment in fusion energy. A new article was recently released addressing the recommended DOE investments and support for the core missions of Lawrence Livermore National Labs National Ignition Facility, or NIF, which primarily focuses on the development of inertial fusion energy. These recommendations from the DOE's Fusion Energy Science Advisory Committee came from the FESAC report called Powering the Future, Fusion and Plasmas, issued back in December and was quickly followed by the National Academies of Sciences, Engineering, and Medicine NASEM report, which called for aggressive action to build a U.S. pilot fusion power plant as soon as 2035. Both the FESAC and NASEM reports focus on the development of magnetic fusion energy technology. However, this technology highlights how both reports also acknowledge the need for parallel pursuit of other government and private fusion technologies, which include inertial confinement fusion. According to FESAC report subcommittee member Tammy Ma, while the total funds Lawrence Livermore National Labs receives each year from FES is small compared to what we receive from the National Nuclear Security Administration, the path that fusion energy sciences charts has always had a significant influence on the trajectory of fusion and plasma research at the lab. This report now establishes a strong and coordinated plan for fusion energy and plasma science for the next 10 years in the U.S., and Lawrence Livermore National Labs has an important role to play. The FESAC report includes recommendations to fusion energy sciences and provides a research and development technology portfolio under 3 budget scenarios: a constant budget, a modest 2% budget growth, and an unconstrained budget. To get a sense of the specific recommendations dealing with inertial confinement fusion, a few include restarting an IFE program under the no-growth budget scenario, coordinating a high-intensity laser research initiative, FES in collaboration with other federal agencies, pursuing the development of a multi-petawatt quadrillion-watt laser facility in a U.S. high-repetition rate, high-intensity laser facility similar to the high-repetition rate Advanced Petawatt Laser System, or HAPLS, constructing and designing a mid-scale Z-pinched pulse power facility, preferably in partnership with other agencies. While the FESAC and NASEM report lay out the future plans for inertial confinement fusion development, this next piece of fusion news gives insight into the advancements happening today. 3. Team improves polar direct drive fusion neutron sources for use in laser experiments. A team of scientists from the Lawrence Livermore National Laboratory and the Laboratory for Laser Energetics have been working on improving polar direct drive, a type of neutron source used in the National Ignition Facility. As a quick reminder, the National Ignition Facility uses high-powered laser beams with energies up to 2.1 megajoules to heat and compress tiny amounts of deuterium-tritium hydrogen fuel capsules in extremely short pulses, around 200 to 300 picoseconds, to create inertial confinement fusion. 14 MeV neutrons are created during these experiments. The NIF's test platform is a great way to perform neutron source experiments with these escaped 14 MeV neutrons. According to team lead Charles Yeaman, the team wants to study how the intense radiation fields generated from fusion affect materials, electronics, and engineered systems like satellites and airplanes. And at NIF, scientists can control and position the test objects very close to the neutron source for controlled testing, especially when using polar direct drive. The collaborative team made substantial enhancements with the polar direct drive setup. They saw improvements in the total fusion output and the laser to fusion energy conversion efficiency. In addition, the team developed a polar direct drive exploding pusher platform so that they could radiate test recoverable samples at record 14 MeV levels. According to Yeamans, over a year and a half after the initial experimental success, this design of polar direct drive was the most efficient way in existence to convert laser energy input into fusion output. The work also developed the modeling and simulation capability to understand and improve the neutron source design. With this work, we are better able to fulfill this responsibility now and in the future. In addition, similar direct drive capsule platforms have even more applications, such as studying astrophysics phenomena or creating short pulses of continuum X-rays for X-ray absorption studies and opacity measurements. 4. Phoenix receives $2.5 million contract from DOE for fusion energy technology. Phoenix, a private company based in the U.S. working on manufacturing accelerator-based high-flux neutron generators, received a $2.5 million cooperative agreement jointly awarded by the Department of Energy's Office of Science, including Fusion Energy Sciences FES program and the Advanced Research Project Agency Energy, or ARPA-E, under its Galvanizing Advances and Market-Aligned Fusion for an Overabundance of Watts, or GAMOW program. Phoenix makes neutron generators. Neutrons are produced by fusion reactions when a beam of deuterium ions is fired into a tritium gas target. The $2.5 million in funding will go towards the project titled Ultra-High Flux DT Neutron Source for Accelerated Testing of Fusion Materials in Subsystems to Reactor-Relevant DPA Levels. This project aims to develop an advanced plasma window designed to increase the strength of Phoenix's neutron generators by at least a factor of 100. If successful, the technology will be integrated into Phoenix's commercial steady-state gas target neutron generator, which will enable accelerated testing of emerging fusion reactor materials and subsystems. This materials testing will ultimately reduce the technical, financial, and regulatory risks of fusion energy technologies. A laboratory demonstration of the Plasma Window project is scheduled to occur in late 2022. This cooperative agreement creates excitement across both the private and public sector. ARPA-E's GAMOW program director, Dr. Scott Hugh, says, "The GAMOW program supports innovative R&D to close technological gaps needed to connect a net energy gain fusion core once it is ready to deployable, commercially attractive fusion energy systems. We are eager to work with the Phoenix LLC team through GAMOW to develop their technology, which could accelerate the testing and qualification of a range of materials needed for a future fusion pilot plant." 5. Atkins wins design contract for world's first fusion energy research center. Atkins has been appointed by the UK Atomic Energy Authority, UKAEA, to help design the world's first center for research tritium for use in fusion energy. The Hydrogen 3 Advanced Technology Facility, which will be built at Culham Centre in Oxfordshire, will support ongoing work at ITER, the world's largest fusion experiment, which is currently under construction in the south of France. It will also allow academic and industrial users to research how to process, store, and recycle tritium, one of the fuels that will supply fusion power stations. Tritium breeding and processing is one of the key technology development areas en route to commercial fusion. And here are some bonuses. Shiny Happy Future, Shine Phoenix merger focused on advancing fusion technology. Melanie Windridge wrote a great article outlining the merger, or re-merger, of Phoenix and Shine. Phoenix being a private nuclear technology company and Shine a private medical isotopes company, both founded by Greg Piper. The article discusses the history about each company and outlines Greg's 4-phase progression to clean energy production. If you haven't already, check out our monthly Fusion News Extra podcast that do a deep dive into one of our recent news topics. The last one was on Australian fusion startup HB11 and their oversubscribed investment round, and we'll have a new episode coming out next week. Well, with that, I hope you enjoyed our news and learned a little bit more. And that's all for your Fusion News this week. Please like and subscribe for more Fusion News and check out the links in the description below and show notes for further information. See you next time.